I've been working in the IT industry now for 25 years. It's nice to actually listen to the questions and listen to the subjects, and maybe I can help answer some of these questions. But before we get there, has anybody heard of Amazon Web Services before? Nosta kädet ulos, jälleen jolla. No niin, kaikille, yay! Okay. Actually, we are some kind of startup. So today I'm going to be talking about sustainability and AWS. Why sustainability on AWS? Everything that you've heard this morning, you are going to build it somewhere, right? Whether it be your PC, whether it be in a data center somewhere, or whether it be on cloud. And this is going to be the story about how AWS looks at sustainability and how we help our customers to actually attain their sustainability. So the question was, how do we actually measure the carbon footprint of an application? Maybe at the end of this presentation, you get some kind of idea of how we do it. So, a couple of topics, just the Amazon sustainability pledge, AWS and the sustainability scope, and then basically a real life story from a customer. Okay. So in 2019, Amazon and a company called Global Optimism formed a fund called the Climate Pledge. The reason for this fund or this initiative was basically to try and reach net zero carbon by 2040. So for those of you all that are in sustainability, there's the Paris Agreement that says we should try and reach net carbon zero by 2050. But Amazon and this company called Global Optimism decided we were going to do it 10 years earlier, right? Quite a big, ambitious target. So far, we have more than 400 companies that have signed up on this. You see the big names like Microsoft, IBM, any of the companies that Coca-Cola, and in the Nordics, we have more than 22 companies that have signed up onto this. But what does this mean? What it means is, if you sign up to this pledge, you are signing up to report your carbon emissions on a regular basis. So that means you have to be vetted, you have to be officially go through a process of understanding your carbon footprint. How do we measure it, right? And actually reporting this to the public. Then, wherever you see that you can eliminate carbon, so where you can actually optimize your applications to reduce compute power or RAM or any other IT resources, you should do that and actually report it. And then the third one is, where can you actually not reduce carbon? And how do you deal with that? So for example, for those of you that know about data centers, they are made from concrete. Concrete contains carbon dioxide. How do you actually get rid of that carbon dioxide from something that has been built 10 to 15 years ago? You can't really do that unless you break it down. So what do? You look at other sources of carbon offsets, like for example, planting a forest to actually increase the absorption of carbon dioxide. And that's what the pledge is about. It's about signing up to actually make a difference at the end of the day. So it's not just, hey, let's sign on a piece of paper and then hope for the best later, but it's actually following and measuring your progress as a company to getting to net zero carbon by 2040. Cool. Amazon's a big company, and so is AWS. But why I like this slide is because it tells us what we are doing in the Nordics, right? And specifically in the Nordics, there's many topics that are listed on the slide, but the biggest one for me is the one where there's 9 wind farm projects now in Sweden and Finland. And that's going to generate electricity of 950 megawatts or more. So big investment, right? Also, for those of you that are familiar with the AWS services, and if you are deploying any services, in the Stockholm region, over 95% renewable energy is used. And that's something that we actually measured on. Renewable energy. So we need energy to run data centers, to run computers, to run applications, to run the mobile phones. Basically, what that means is that we consume more and more energy as we increase our IT workload. But what's happening from the AWS perspective is that we are actually investing in renewable energy. And when we started back pre-2016, it was nearly negligible. When we look at it today, we are pretty much over 90% of our target on renewable energy. And we continue to increase that until we get to 100%. So what does that mean for your applications? It means that if you are running an application in AWS, that you are running on renewable energy. A small piece of getting to carbon, net carbon zero, or making your application carbon neutral. I like this slide because it's a very techie slide. Basically, what the slide is showing is it's showing 13 windmills on each line. So each line is basically the power output of each of the windmills. Now, Amazon is running 400 plus renewable projects around the world. To go in and measure every single windmill or every single solar panel is impossible from a human perspective. So how do we do this at scale? We use AI ML. What this picture is showing is on the x-axis, the time, and on the y-axis, how much of energy is actually output by each of those windmills. Where you see it's red, that's the most optimal time that the windmills are producing electricity at most efficiently, right? Where you see it's yellow, green, or blue, that's time where we have to think about a different source of electricity. Do we get it from solar? Do we get it from hydro, right? So these are small parameters or AI ML that's going on in the background that's actually optimizing the amount of renewable energy that we use and how we actually use it. So we try not to take energy from renewable sources when it doesn't make sense to. We find another source of energy. And again, it goes to running your applications and your workloads on cloud. Basically, where the blue line is, those windmills are in maintenance mode. Something is being repaired, so we don't actually use any energy from those windmills. It doesn't make sense to, right? Because if we try to get energy from them, it means that we're getting very little, and we have to compensate from another source in order to increase that, to meet that energy consumption. By the way, anybody on Persisaka? Today is very cheap because of the Myrsky yesterday, right? Same thing. So, sustainability. We look at it in two ways. Sustainability off the cloud, which is our responsibility, and sustainability in the cloud, which is our customers' responsibility. So we take care of the infrastructure, we take care of the concrete, the servers, the cooling, the water, data centers, electricity supply, and you take care of the applications, right? And in a couple of slides, we'll cover how you actually do that. Or we have a couple of principles to share with you. So sustainability of the cloud, basically we have what we call regions around the world, or data centers if you want to call it, globally. Our closest right now is in Sweden. What we've done is, or what an independent study has done, is the efficiency of using cloud versus your own data center. And what they've come up with is that in Europe, you can get up to 5 times more energy efficient services from cloud rather than your own data center, right? So for customers that are running workloads on their own data centers and they're looking to reduce their carbon footprint, cloud is an option for them. Okay? And how is that actually broken down? So I come from a background where I help customers understand what is their workload currently running at in terms of CPU cycles. And what we usually see in the industry is that there's about a 20% utilization of a server. That means that your application is only using your hardware 20% of the time. For the rest, 80% of the time, you're paying a lot of electricity for it, right? So what we what we take care of is actually managing those servers. And when we look to manage the infrastructure, we can actually get more efficiency out of it than you can from one server. So when you look at the carbon footprint, 67% of it is basically the energy that is used to manage those servers. And if you use them efficiently, then basically you're getting the best out of those servers for the amount of electricity that it's consuming. Data center facilities account for another 13%. So if you do this at scale, you are more efficient. And then basically the last 16% is as you increase your renewable energy, you start to get more efficient on actually using your electricity sources. So that's how it's kind of broken up. As you can see, reaching 100% is pretty tough, but a goal that we never give up on. And then basically something that I touched on earlier. So when we look at offsetting carbon and reducing our carbon footprint for our customers, we look from the bottom up. So we look at how do we actually pour the concrete into the ground? What are the materials made of? When the data center is actually broken down, how is that recycled? So we start all the way from the ground. We look at renewable fuels. So for example, when there is no electricity, how are we actually running the data centers? What type of fuels are we using in the background to actually run those data centers? When we look at actual servers, how are we looking at the newer technology that's coming out and how we're utilizing that? And then pretty much what we are saying right now is, as of this year, 19 regions in the world for AWS is now running on 100% renewable energy. So when we look at sustainability, what we try to do by design is eliminate excess materials. So we design for optimization. Anybody receive an Amazon package lately? Did it come in a big box or a small recyclable envelope? There we go, right? So there's proof for you that we're working on it. When we try to operate our hardware, we try to extend the life cycle of the hardware as long as we can in order to reuse it. And then when we basically recover, if, for example, something faulty comes back, we try to actually repair it and send it back out rather than sending a new one. So these are small principles that we are using as Amazon and AWS to actually help sustainability and our customers. Water, something that Finland is very lucky for. So we have lots and lots of water, so no water problems here, right? But in most of the world, there are water problems. Data centers are one of the largest consumers of water. So how do we actually give that back? What we're doing is we're investing in technology on actually how to give water back to communities. So by improving the technology that's currently in the data center, we are actually trying to return more water than we actually use from the data centers back to the communities. And that's an ongoing process where we're working on it. Basically, these lines mean that we've pretty much reached these goals, but I'm not going to go into them too deeply. I want to focus more on the application side. So this is the part that you guys are interested in, right? Sustainability in the cloud. And basically, sustainability in the cloud starts from how do you actually consume the resources that you're using, CPU, memory, storage. So what we are doing is, this slide is basically telling you we are investing in new technology, in new CPUs. We are actually, when you look back 20, 30 years ago, there were some chip providers that were in the market, but now it's expanding to more chip providers. And for example, AWS is actually creating its own chips. It's manufacturing its own chips in order to manage those workloads more efficiently. Cool. Then we come back to the question of how do you actually measure the application CO2 footprint, right? So within AWS, as architects, what we do is we use this concept called well-architected sustainability pillar. What does it do? It covers 6 areas of where you're going to run your data. So for example, I mentioned there are 19 regions where there's 100% renewable energy, right? Out of 26 regions. So you can choose where you want to run your workload. Alignment to demand. So for example, if you know on a Monday morning that everybody is going to walk into work and turn on their PCs, do you want your applications to be ready for that demand? Also, for those of you that run test systems, who turns off the test systems on a weekend? Everybody forgets about it on Friday and goes home and it's there on Monday morning, right? But you've got a test system running on a weekend where nobody's using it. Why have it running? Right. Data. Anybody have the problem of keeping too much data and never ever looking back at it? I do. There we go. Right. Software and architecture, right? We're going to talk about this in the next slide. So this is an independent study about the languages and the amount of CPU time and memory each of the coding languages, programming languages take in terms of server utilization. And it's something that I like to follow. It's basically run on SLES 17 back in the day, and it's now updated to SLES 21 for those of you that know Linux. If you don't know Linux, don't worry about it. But basically what this covers is the different programming languages running on a Linux system, and what you see here at the bottom is the energy, the time, the CPU, and the memory each of the languages take. Right. So if you're interested in how efficient is your language, programming language, there's data for you. And then the question was, how do we actually measure our application carbon footprint? So in AWS, what we've done is our customers have been asking us for this for a long time. And so we've decided that we would release something called the Customer Carbon Footprint Tool. What that does is that actually measures your carbon footprint of your workloads running on AWS. Now, it takes into account the fact that you have renewable energy, the technology that's behind it, and also your applications and how they are running. Sorry, there's some PowerPoint challenges. But anyway, going back to how to run an application. So basically in AWS, as solution architects, what we work with our customers on is basically how to solve their problem using technology. And the first thing we talk about is serverless. Anybody heard about serverless before? Cool. 1, 2, 3. In a nutshell, serverless is basically you have code. Usually you run it on your laptop or you run it on a server. But how about taking that code and running it only when it needs to run? So for example, somebody presses a button on a website and then the code is invoked. And that code is actually run somewhere that you don't know about and you don't care. You just want the code run and returned, right? And that's serverless because you don't have a server in mind. We take care of that for you, right? Asynchronous. So using actually providing data to customers when they actually need it, not keeping it alive all the time, right? Scaling, basically, use what you need in terms of compute. So if you need 1 server, keep 1. If you need 5, scale out to 5 when you need it, and then scale back down to 1. Then we talk more about the AWS managed services. I'm not going to go into them because there are quite many of them, and it would take a long time to explain all of them. But basically, we cover this service and patterns to optimize for utilization. And there are many services and patterns depending on the workload. Cool. And then the last topic is sustainability through the cloud. What is sustainability through the cloud? So for a long time now, companies have been collecting data, and they make this data available through cloud, right? One of the companies that is advertised here is the Finnish Meteorological Institute, Ilmatieteen laitos. You can go to their website. They have something called an S3 bucket, where they have all the data records for the last 2 years hosted on AWS, publicly open. You can go and extract that data and make your models out of it, your own weather patterns. So if you're into learning about what the weather was for the last 2 years, it's up there, right? And this is what sharing data is about. So you can, in terms of collecting data, if the data is out there and it's shared, you don't need to go and recollect it, right? You just use it. So that's a way of optimizing how your application actually uses or reduces its carbon footprint. Instead of going to reinvent collecting the data, just use it. And then this is a customer story, right? Basically, a customer called Bayer Crop Science, they wanted to look at the carbon footprint for their customers when it comes to food production, right? What we did was we helped them build a carbon emissions data tracked from the farm corn to the farm and also to the factory and then to the final purchaser, right? And that included going back to what is the soil composition, how is the corn actually collected, how is it transported, where is it transported to, what type of fuel is used, all of this data that was collected in. And basically now Bayer Crop can tell their customer, this is how much of carbon dioxide is produced by producing this product, or when you consume this product. Okay. And this is a kind of slide that goes into when you're looking to create that carbon footprint consumption from source to end. And this is just an example of materials, waste, air quality, energy, whether it's IT or electricity, and for example, building design. Cool. This is my second last slide, I promise. Right. So the question is, how do you measure CO2 emissions of your application? There's a lot to think about when you actually do it, right? And then sustainability for me is a big thing, right? Because for one, you can see the weather patterns changing. For two, you can see many things happening around us, like our GESA is moving 3 months earlier, right? Anybody know David Attenborough? Some people, yay, cool. So he said a couple of years ago about sustainability, we can't cut down rainforests forever. And anything we can't do forever is by definition unsustainable. And I'll leave you with that thought. Thank you.